Hello all, welcome to my channel Tech Surf with Vamsi. Today in this video we are going to learn about the Java class data sharing, the functionality which is available since JDK 5 but not many of us uses it. What is CDS? Class data sharing. Traditionally when you run the JVM, it loads the classes like integer, string by default or any other deployable classes that you have in your system class path into the JVM. For that, it has to read the jar files in the class path, load the classes, read that information, and put it into the JVM. So what if that information is already available as a shared location, as a shared file, so that it doesn't have to read the class path every time. The class information is already available, it's just that it has to load it into the JVM. That reduces the startup time of the JVM. Let's start with how this works, right? So starting from JDK 12, the JDK is shipping this default classes.jsa file. It will be created automatically when you install the JRE. Even if it doesn't create, you can also create at any point of time. But let's see like where is that classes.jsa, for example. If you see, so this is the file that has the default, some of the classes that you usually load. I mean, knowingly or unknowingly, even the JDK util, Java util, and Java lang packages. So this one can be generated at any point of time. Let me show you like how that works. So if I go to, let me show you here. So you can say, so let's say run this command. So this is a Java command, simple Java command, and if you click Xshare dump, it can be recreated at any point of time. We don't have to do this at any point of time because it already came up as part of the JDK 12, but if you really want to do it, you can still run this command, and that generates a new file with this new timestamp. And now let's see how does it different, like what difference does it make to start with. So I have a simple program. So it's a Spring Boot program where it starts up. I have a simple main app that tracks the start and startup time of an application. So we'll say like how it is reducing the startup time of an application. So for that, I just took the start timestamp here, and I created a controller, and I'm listening to an application ready event, and I took the start time. So basically, I'm taking the time difference between the start of an application to the complete startup. That means the startup time to load the classes, initialize any of your default connections to database or anything. It tracks everything. So let's get started. So I'm running my application. So here, Spring Boot jar. So it doesn't have much, so it will start up within very few quick up. Let's see it starting up in 2.3 seconds, and I can see the startup time here. It is 2.5. A few milliseconds will be here and there, but that's the actual startup time of my application. But now, how do you know that it is loading the classes from the JSF file that we are showing here, or it is loading the file from the by default rt.jar? So for that, there is a tool developed by an amazing Java developer. So this is a tool. It's not by me, and I'll show you the link in this video. But this lag parser, this tool will help you to know how the classes are being loaded from in your JVM. Is it loading from that JSA file, that CDS file, or it is loading from rt.jar? So let's just start with an option. By default right now in JDK, it always loads the classes.jsa file. It's a default option, but you can always come back and then try to turn it off as well. So while you turn off, I'm using this command. For example, let's say so for example, you can say minus Xshift off. Again, this is not recommended. So this is share off. So again, this is not recommended in your production environment. Don't do this. So I'm just trying to provide you a demo purpose as well. Just for this is just for demo. So if you run this, share off, then it doesn't use us that class.jsa file. It always load from the rt.jar. So now let me show you how that works. Let's start the application. So this, if you see now, the time taken is 2.929 seconds. So that increased the startup time from earlier. And also we can see in the log file, I have that cds-log-parser downloaded in my local. So if you see, if you provide, try to run this jar and provide your cds-log file location, which is nothing but my Spring Boot. So this location. So here, if I go back, it can tell you how many classes are loaded from the jars and how many classes are loaded from, what is the percentage of classes loaded from the default. So if you see, nothing loaded from the cache. So everything loaded from the jar files, So try to do the same thing without, by using the default option. So let's say I'm removing this option, which we should remove in our production environment. So let me try to remove and then run again. It will generate the cds-log file again. And now you see that automatically the startup time is reduced. So you can clearly see this one. So now go back to cds-log-parser and run that command again. Now you can clearly see that some of the classes are loaded from the cache file. So the cache is nothing but this, your classes.jsa file. So by default, it loads from this file. So all the time that you're trying to do that JVM tries to do to read the jar files loaded from the class will be saved. So that's to start with a regular, the CDS option that is provided by JDK. So friends, our goal is to reduce the startup time of our application. So there are multiple options available, but one of them is, if you observe this, for example, if I go back to my application, so if you see, I am using the Spring Boot jar. It's like an open jar of jars, right? So if you run this, Spring Boot Java is gonna take some time because all the jars, internal jars like Tomcat, everything is embedded within this jar file. So it has to first extract it and load it. So that takes an additional time. So some of the cloud founders, like for example, PCF, Spring Pivotal PCF. So what that does is by default, it extracts this jar file to an extracted location and then start up. Right. So now let's see how we can further drill down. So you can also extract this. So by running this command like java -d Djarmode tools jar libs Spring Boot extract. So now we see it will generate this file, right? So now what we do is we're gonna execute. So what we do, so let's say Spring Boot, we're gonna run this jar from this one. So, and you can automatically see that it started now like 1.908 seconds. So it drilled down. So the time it is saving some time to start up. So if you see again, it came back to 2.12, and you can see that the time that we are saving here is, instead of loading the over jar, it extracts this jar to all the lib files. So you are not going a jar of jars, you're directly reading the jar file, and that saves the read time here. So that is one added benefit that comes with, if you are using Pivotal Cloud Foundry. So moving on to our next thing called application CDS. So what is application CDS? So we have seen the default CDS where JDK is shipping the java.lang and some of the default packages that we are loading as part of the application. But what if you are trying to load other jar files like the Spring, Tomcat, anything else that's packaged with your deployable? So you can also create an application CDS file that's like a custom file, JSA file that you can create, and you can reuse that same file every time and save the startup time. So to do, I think this option is started available from JDK 10, and let's see an example how you can make this work with straight JDK option. And also Spring came up with the similar option, and they do things a bit different, but let's start with how JDK is doing this. So let's run so you can, let's say, go here and you provide this option ArchiveClassesAtExit, and you can provide your file name, like I'm just giving it as application.jsa, and then start the application. Now it started and it all does the same thing, but and you go Control C, it will create this JSA file in in your local. So this is the JSA file that is created, and then what we'll do next time is use this JSA file. I'm going to run another command to use this JSA file. So what I would do, let's take this command. So let's read this command first, what we're exactly trying to do. So we are trying to reuse this application Java's JSA file. And this time what we're gonna do is I'm using the cds-log-parser to show you like how many classes are loaded from this JSA file instead of the system class path, and then run it again. So let's go with this option and then put. So now let's see. Now you see automatically that this time taken reduced to 1.4 from like 1.9 or 2 seconds. It's half a second has been reduced again. So that is 25% of the time. So now if you go back to cds-log-parser and then take a look at see how much is loaded. So now here, if you see, all of the Spring Framework classes, like 99% of them loaded from the JSA file. And then if you see the Hibernate, earlier if you see when you compare with the old output, so as we are using only classes.jsa, it is only loading the Java classes, but now you have your custom class. So this is so now the all Spring classes also loading from this cache file. So that is one default JDK option that is being provided. What you can do is, in Spring comes up with another option called the Dspring.context.exit. So what this is doing is, you don't have to run your whole application to create the application.jsa file. I mean, this is a file. So here in this case, jar JDK, the trial run is first time you have to run, bring it up, bring it down properly. But what Spring is doing is, here, let's go back. Spring comes up with another option, like here you don't need to do all this. So 1 minute. So Spring comes up with this option called Spring context exit on refresh. So this is the Spring calls it as a trial run. So what the trial run means is, it doesn't bring your application up. It will just start up, load all the classes, create the file, and exit. So if you see this, it will start up and immediately go down. So what it does is, it's just a trial run. It will create that file by default and it exit, and next time you can use the same file to bring up your application. So that's about the application CDS file. Next, start with dynamic CDS. The difference between application CDS and dynamic CDS is, in order to generate the application CDS, you have to start the application and have a trial run, and then generate the application .jsa file. But this dynamic CDS is an option available from JDK 13. For that, you don't have to bring down the application or do not have a trial run. You can take the dump while application is running. And again, it may not be suitable for production environment because it had to have a just has to stop, doing certain processing at JDK level, but JDBM level. But this is one option being provided. You can generate this, generate the JSA file dynamically, CDS file. The way you can do is by using this option RecordDynamicDumpInfo, and you press enter. So we need to track this process ID. So if you go up, because we need this ID to run the dump command. So I say clear. So let's say jcmd VM.cds dynamic dump. So you see, it will generate the dynamic dump file, and with this process ID, so it will generate this file, and you can also see in the actual log that it's trying to generate this dump file here. So next time when you come up, so what you can do is you can use this dump file. For example, I'm going back to this, right, and then say java pid 40384 dynamic.jsa. So now let's enter. So it will start the application. If you see, it's the same time 1.404. So now it's just that it using the file that is being generated dynamically. So now that we know the default CDS, application CDS, and dynamic CDS, let's talk about the limitations of it before we move further. So we have seen that it is helping reducing the time taken to start up the application. But what are the limitations? The limitations are that we must use the same JVM. Like, we can switch JVM versions. Let's say you cannot generate, let's say you generated an application file, custom app CDS file using one JVM version. Then when you want to use this file, you should use the same JVM version as well, and same operating system as well, Linux or Windows, right? But it cannot be like, a different JVM version and different OS. And the second thing is, whatever the class path you have used to load this JSA file, to create the JSA file, the same class path should be used. Maybe you can add it at the end, but you cannot change the class path. And also, we cannot, let's say if you rebuild the application and you try to use the same old or the already generated application JSA file, then it doesn't work because when you rebuild the application, the timestamp of your jar has been changed. So that is another limitation. So it will help. Let's say if your build is finalized, then you generate the JSA file, and then you take the same JSA file for the JVMs in a shared location, start using it rather. But if you rebuild it again, then you have to regenerate the CDS file. So now that we have seen the limitations of CDS, now let's move to the last point which I'm going to share today is CRaC. So what is CRaC? CRaC is a coordinated restore at checkpoint. So what does it mean? So it's like a checkpoint of your JVM, which takes the complete heap dump, your class information, your memory, and everything, except some things like your connection information. So like when you say you're connecting, when you connect to the databases and all, like or establish any remote connection, excluding them, what this does is it takes the complete checkpoint at one specific point of time, and you can start an application from that point onwards. And this is really benefit. It gives a big benefit when you are using any lambdas or functions deployed on the AWS, where we need a very minimal startup time, like in milliseconds, not even in seconds. It has to start in milliseconds. So for example, let's see, in order to so this CRaC doesn't work on all the OpenJDK versions. It has specific JVMs only support, like enterprise JVMs or AWS, Amazon Azul JVMs. So in order to demonstrate this, I actually, it also doesn't run on the Mac or Windows. It only runs on Linux. The CRaC is supported only in Linux. So for that, I'm running, as you can see, this is a MacBook. So I used a Docker container to use the Linux Ubuntu operating system and also an Azul JDK. So let me show you quickly and how that works, and then I'll show you how it is a big benefit if you use the CRaC. So in order to start using the CRaC, you need to include the CRaC as an open source one into your Gradle file. So the CRaC jar must be presented, and before going there, this is a Docker file that I have. So if you can see, I'm using Ubuntu operating system, and I'm also installing the Azul JDK 21 version, and also and I'm extracting them as well, and I am copying my Spring Boot jar into the Docker, and then I'm exposing the port 8080. So let's run the Docker file. So first of all, I'm already create the Docker container. So if you see, it is created, it has been created, the Docker container with this name. And all you have to do is to run the Docker container with the privileged options, right? And I'm exposing port 8080 with the same Docker container. Let's just start this Docker container. So now let's see, like a quick look at the Docker image. I'm into this Linux operating system within this Docker. So if you see, we have uploaded our local jar file here and create some few empty directories. If you see, the directory is empty right now. So now in order to run this application, so let's say go here and then say start this application by using the CRaC checkpoint. So, and then what you do is, like, let me try to use the no hub. So what this is telling you is, okay, when we take the checkpoint, save the files, images to CRaC files here. So let's take a look at the process ID, because we need the process ID to take the checkpoint. Before that, I would like to show you that it also saves the heap memory. So for example, let's say I am saving some of the names into my local map here. So let's say, and then say get, right? So when you say get, so it will give you all the it will give the names here, right? So it is a local map that I just created, all because I want to show you that it is taking the checkpoint along with the heap dump, not just any class information. So now let's go back, right? Let's take the checkpoint now. The process ID is 10 here, and then say JDK say checkpoint, right? So now it took the checkpoint. So now if you see, it now the jar, so this is your checkpoint image. Now let's say when you come back, so what you need to do is, so all you need to do is just restore from this point. So your JVM, so if you see, you don't have any more JVMs, right? No, sorry, the application is not running at all, because once you take the checkpoint, it's done. It will just drop the JVM. So now what you have to do is, what I'm saying here is, let's say, start the application from the checkpoint. So now if you see, the time taken to start the application is 49 milliseconds. It's way down. It doesn't need to load anything from anywhere. Everything is available within this VM. So that's how, when you run any lambdas or functions in in AWS or any other cloud platforms, it needs really a quick startup time. It cannot take like 1 minute or 2 minutes. A small piece of code, if you want to run and purely serverless and function based, this is how they're achieving. And if you see, you can restore it. If I refresh it, you see it still retain those details. That means the heap is already retained within the checkpoint, and you can see it started within like 49 milliseconds. So that's a huge, and when you can go back. But if you do the startup time, if you see, it will still say 2.8 because it is storing that content in the heap. and this is pulling from the heap, but actual startup time is 49 milliseconds. So that's it, my friends. Hope this helps to reduce your startup time. And if you like it, if you like this video, please do share, subscribe, and like on these videos. Thank you so much. See you again next time with the new content.